Okay, so our next lesson is Anova versus Kruskal Wallis. So Anova is the parametric test if we satisfy the assumptions or the conditions. However, if we did not satisfy the assumptions and conditions, we are going to use the nonparametric test, which is the Kruskal Wallis test. We have here our data. So as a researcher, come up with a survey getting the ID number of the employee, their position labeled as 1, 2, and 3. 1 is for the manager, 2 is supervisor, 3 is coordinator. And then the gender, 1 for male, 2 for female. Then we have here the performance rated by their peers. We have here also their performance rated by their self or the self-evaluation. And then, lastly, the performance rated by their clients. So that would be our data. So what we are going to do is copy this from our spreadsheets. Then right-click, copy. Then we go to our SPSS, click data view, and then we paste Control V. Okay, or if you want, you can just right click, then paste. Okay, after that one, you are going to notice that we have variance here. We have to change those ones into words. So we go to variable view. Here, we know that the first row that we have is the ID of the employee. The second one is the position. The third one is their gender. The fourth one is their performance. There's no space here, so rated by their peers. Next one is the self-evaluation. And then the third one is their performance rated by the clients. Okay. Then we don't have decimal here. Position also. And then the gender, we remove the decimals. We can remove also the decimals for the performance, self-evaluation, and their performance from the clients. Next, we are going to label them. We go here, then performance given by their peers. Then self-evaluation. Then the third one, performance given by their clients. Okay. Let's go here in their position. We coded the position, manager, supervisor, and coordinator. So we click that. 1 is for the manager. Click add. 2 is for the supervisor. Click add. And then 3 is for the coordinator. Then click add. Click OK. Then for the gender, we have 2 also. 1 is for male. Click add. 2 is for female. Click add, then OK. After that one, we go to the different measures. This is nominal. Position, nominal. Then gender is nominal. However, the 3 is ordinal because we talk about performance. Okay, then after decoding them, we go back to our data view. As you can see, instead of writing numbers for the position and gender, it became manager and supervisor, coordinator, and then male and female. So to check that one, we just click this. So it will become number again, or that one. Next, we're going to proceed now. When are we going to use Anova? And when are we going to use Kruskal Wallis? Of course, we have to test the normality of this one. So we click Analyze, click Descriptive, click Explore, then this will come up. For dependent, for us to test them as one, we put performance, self-evaluation, and then the performance also. Then, the factor list is the position. Then, we go to statistics. This should be 95. Continue. We go to plots. We should click histogram instead of stem and leaf. And then we click normality. Histogram and normality. After that one, we click continue. And then, okay. As you can see, for manager, we have 10. Supervisor, we have 11. Coordinator, we have 10. A total of 31 respondents. Then there's no missing. So that's correct. Then we go down to see the normality of the given figure. Okay. So in here, the performance given by their peers. For the manager, we have 0.550. Supervisor, we have 0.318. For the coordinator, we have 0.096. So, all of these three is greater than 0.05. So, meaning the performance given by their peers is normally distributed. We are going to use Anova. Next, for the self-evaluation, for the manager, 0.126. Supervisor, 0.285. Coordinator, 0.083. Okay, so this 3 again is higher than our critical value, which is 0.05. Therefore, for the self-evaluation, we are going to use parametric test, which is Anova. Next, the third one, performance given by their clients. For the manager, we have 0.004, supervisor 0.002, and then the coordinator 0.008. So the three of them is lesser than 0.05, which is our critical value. So if we have lesser than our critical value, which is 0.05, meaning our data is not normally distributed. So for the performance given by their clients, we are going to use the nonparametric test, which is the Kruskal Wallis test. However, in here, if ever we have only one lower than 0.05, that's still not normal. So we still use Kruskal Wallis. Okay? So in here also, at least one lesser than 0.05, we are going to use nonparametric test. Okay, so we continue now. That is the bar graph of the given data. Okay, so we continue with our data. We have here the problem. Is there a significant difference between the three positions in the company when it comes to their performance given by their peers? We are going to create our null and alternative hypothesis. For our null hypothesis, we have there is no significant difference between the three positions in the company when it comes to their performance given by their peers. Meaning, they don't have any difference. Their performance are all the same, are all equal. For alternative hypothesis, we have there is a significant difference between the three positions in the company when it comes to their performance given by their peers. Okay, so choosing the statistical tool, since we are talking about the performance given by their peers, which we have tested already. For the choosing of the statistical tool, since we have here performance given by their peers, and we have tested the normality a while ago, and we have the result of normally distributed, meaning the statistical test that we are going to use is the parametric test, which is the Anova. Okay, so we are going to run now our SPSS for the computation. We go back to our SPSS. We click Analyze, then Compare Means, and then click One-Way Anova. Okay, so for the one-way Anova, we click the performance given by their peers for the dependent list, while for the factor list is the position because we are comparing three: the manager, the supervisor, and the coordinator. Then we click contrast. Okay, continue. The post hoc. Okay, that should be 0.05. Continue. Then we have the option. We click the descriptive. Continue. And then click OK. Okay, so we have here the description. For the manager, we have 10. Supervisor, we have 11. The coordinator, we have 10. A total of 31. Given the mean also. And then the standard deviation and the other information. We have the maximum, which is the highest, 92. And then the minimum, which is the lowest, 76 for the manager. Then the highest score for the supervisor is 85. The lowest score is 75. For the coordinator, 75 for the lowest. And then for the highest is 95. Okay, then we go now to the Anova. Okay, so the significant difference or the p-value computed is 0.002, which is lesser than our critical value 0.05. So we copy this, right click, copy. Then we go here, right click, we paste. Okay. Okay, so we have here the description, then the Anova. So having this as our data or the computed value, what would be our decision? Since the computed p-value is 0.002, which is lower than the critical value of 0.05, then what are we going to do? We reject the null hypothesis. Okay, so that would be our decision. Since we rejected our null hypothesis, we are going to get our alternative hypothesis. So all we have to do is copy, then paste. There is a significant difference between the three positions in the company when it comes to their performance given by their peers. So it's either one of them is very high, while the two of them is very low, or we can say also that 2 is equal, while the other one is not equal to the 2, or the three of them are not equal to each other. So that would be for the Anova. Next is this problem. Is there a significant difference between the three positions in the company when it comes to their performance through self-evaluation? So a while ago, we have the performance of these three company workers when it comes to their peers. Now, we are going to test using the self-evaluation. So let's start with the formulation of our null and alternative hypothesis. For our null hypothesis, we have there is no significant difference between the three positions in the company when it comes to their performance given by their peers, meaning all their performances are equal. However, for our alternative hypothesis, we have there is a significant difference between the three positions in the company when it comes to their performance given by their peers. Meaning of this, two positions are equal and the third one is not equal to the two positions. Or it can be also that the three positions are not equal to each other. Then we go to choosing the statistical test. We have tested a while ago the normality of the given data. And for the self-evaluation, we have concluded that they are normally distributed. So we are going to use the Anova. So we are going to do the same thing as what we have done a while ago. We go to our SPSS. We click Analyze. Compare means click one-way Anova. So this time, instead of using the performance given by their peers, we are going to use their performance through self-evaluation. The factor is still the position. Then after that one, we click the option for the descriptive. Okay, and then you click OK. So again, we have 10 for the manager, 11 supervisors, then 10 coordinators. Okay, then a total of 31. And then here, we have 0.000. To click more, double click. Okay, so we have here 0.000317 to be exact. Okay, then we copy. Right click, copy, then we go back to our paper. For the computation, Control V. Okay, so we have here the descriptive and then the Anova. So for the Anova, we have 0.000317 to be exact. Okay, which is lower than our critical value of 0.05. Actually, way lower. Okay, so we have our decision. Since the computed p-value is 0.000317, lower than the critical value of 0.05, then we reject the null hypothesis. Okay? Now, upon rejecting the null hypothesis, we rejected this one, meaning we are going to get the alternative hypothesis. So, our conclusion, there is a significant difference between the three positions in the company when it comes to their performance given by their peers. So, as you can see, for the supervisor, the lowest score is 90, while the highest score is 94. Compared to the manager and coordinator, they have a very, very low score as their minimum, 77 and 75 respectively. Then we have their maximum as 94 and 91. Meaning, supervisors' score for their self-evaluation is way higher or way different compared to the self-evaluation of the manager and then the coordinator. Next now is there a significant difference between the three positions in the company when it comes to their performance given by their clients? Okay, so this time we are going to test if there is a significant difference between the company when it comes to their performance given by their clients. Okay, so we are going to formulate our null hypothesis. For our null hypothesis, we have there is no significant difference between the three positions in the company when it comes to their performance given by their clients. And for our alternative hypothesis, there is a significant difference between the three positions in the company when it comes to their performance given by their clients. So choosing the statistical tool, we go to analyze, then we are going to click descriptive statistics, then we click explore. So instead of using the three of them, we are just going to select this. Then we click OK. Okay, then we go all the way down below. Okay, 0.004, 0.002, 0.008 for managers, supervisor, and coordinators, respectively. These significant figures are lower than 0.05 as our critical value, meaning our data for the test of normality for the performance given by their clients are not normally distributed. So instead of using Anova as our statistical tool, we are going to use now the nonparametric equivalence, which is the Kruskal Wallis Test. Okay? So our statistical test is the Kruskal Wallis Test. Okay? So we go now to our computation. Going back to our SPSS, we click Analyze. Since it's Kruskal Wallis, we click Non-Parametric Test, then Legacy Dialog, then we click K Independent Samples. K means 3 or more samples that were being tested. Okay, so we click that one. And then for the test variable, we are going to put the performance given by their clients, and of course, the grouping variable that's still the position. So we have 3 positions. And then we are going to click define range since we have question marks there. Okay, we have here minimum and maximum. Our minimum is 1, that is for the manager. 2 is the supervisor, and then 3 is the coordinator. So 3. Then click continue. Then we click options. Okay. Click descriptive. Continue. Then Kruskal Wallis should be checked here. Then after that one, just click OK. Okay, so we have here the descriptive. We have 31 respondents. The mean is 79.61. Then the other values here. The highest score is 98, while the lowest score is 75. Okay, then our concern here is this one, test statistics. The significant difference, which is 0.428. Then we copy the descriptive statistics, including the test statistics. Then click copy. Then we go here. Then paste. Okay, so we have the test statistics here and then the descriptive statistics. Okay, so we have here now our table computed already. 0.428. So our decision, since the P value is 0.428, which is higher than the critical value of 0.05, then we accept the null hypothesis. Okay, so that would be our decision. So going back with our hypothesis, since we are going to accept our null hypothesis, this would be our conclusion. Okay, so the conclusion states that there is no significant difference between the three positions in the company when it comes to their performance given by their clients. So meaning their clients gave them the same performance, the same scores for the three positions. So that would be for the Kruskal Wallis. Remember that if we talk about Anova and then the Kruskal Wallis, we are testing more than 2 samples. We are going to test if there's a significant difference between the 3 of them or there is no significant difference between 3 of them.